Commercial aviation is widely recognized as one of the safest modes of transportation in the world. Continuous improvements in aircraft design, pilot training, and regulatory oversight have significantly reduced accident rates over the past decades. However, when catastrophic in-flight failures occur, such as loss of aircraft control, severe onboard fire, or mid-air structural breakup, passengers currently have no effective survivability option. Existing safety systems are designed primarily for controlled emergency landings and post-landing evacuation scenarios, not for unrecoverable events at altitude. This limitation represents a critical gap in the aviation safety market. Although such catastrophic events are rare, their consequences are severe and highly visible. A single accident can result in major loss of life, long-term damage to airline reputation, decreased passenger confidence, and increased regulatory scrutiny. In the aviation industry, safety is not only a technical requirement, it is a core driver of market trust, operational stability, and long-term value. Current investments in aviation safety focus heavily on accident prevention and redundancy. While these efforts are essential, they do not address the question of survivability when prevention fails. This creates an opportunity for safety innovations that expand the protection envelope beyond conventional limits. The market increasingly values technologies that can mitigate worst-case outcomes, even if those scenarios occur infrequently. The Emergency Capsule Ejection System, or ECES, is designed to address this unmet need. ECES introduces a survivability mechanism that operates independently of aircraft recovery. In the event of an unrecoverable emergency, the system enables a controlled separation of a fuselage-based capsule from the aircraft. The capsule then deploys a multi-stage parachute system to achieve a stabilized descent, while integrated life support systems provide oxygen and thermal protection during high-altitude conditions. Impact attenuation mechanisms further ensure survivable landing conditions, and tracking systems enable rapid post-landing recovery. From a market perspective, ECES is relevant to multiple stakeholders. For passengers, it directly addresses the fundamental concern of survival in worst-case scenarios. For airlines, it represents a potential future differentiator in safety leadership and public confidence. For aircraft manufacturers, ECES offers a pathway toward next-generation safety architectures that can be incorporated into future aircraft platforms. For regulators, the system aligns with long-term safety objectives focused on reducing fatalities and improving emergency outcomes. In conclusion, ECES targets a critical and currently unaddressed segment of the aviation safety market: survivability during catastrophic in-flight emergencies. By expanding the scope of passenger protection beyond existing systems, ECES represents a forward-looking approach to aviation safety innovation and highlights a potential direction for the future of commercial aircraft design.